Hey, welcome back. Lesson 4 starts on 667. Whoa, I lied. We're going to go to 672. Let's just go to that and start solving some of these equations, shall we? The more practice we do, the better off we'll be. So we're just going to, I know the directions say circle the equations you can solve more efficiently with one way or the other, but we're just going to start solving some of these. And again, I might do them different ways. There are different ways to do these, and no way is better than the other necessarily. It's whatever you enjoy doing. So let's actually just figure this one out. Like this one, this is log base 4 of x plus 3. One way to get rid of that log is we can raise 4 to this power. Because this is the exponent that when I put it on 4, I get x plus 3. So if I put that whole exponent on 4, guess what I'm going to get? X plus 3. What? But if I raise this side as a power on 4, I have to do the same thing over here. So I have to do this would be 4 to the 1/2 power. Now I know that 4 to the 1/2 power, 1/2 power is a square root. So 4 to the 1/2 power actually just equals 2. And we can check that with our calculator. I know some of y'all don't believe me, but 4 to the 1/2 power when we figure it out equals 2 because the 1/2 power means square root. So now we just get this really easy equation here with x plus 3 equals 2. So we can subtract 3 from each side and we get x equals -1. Now, here's where we got to be careful. We got to check that argument can never be negative, right? That's one of the things we learned from the last lesson. But here when we solve it, we get x equals -1. But when I plug it in, it's -1 plus 3. So that ends up being positive. So we're good to go. That is one way to solve this problem right here. Let's just keep solving, and then we'll find different ways to do it. Let's go to B. We have log base 4.5 of 9 equals x minus 1. You know what I would do with this one? Because these are all numbers in here. There's no variables. I can just pull up the calculator and figure that out. Let's do that. Let's just pull up the calculator. I hit math. We'll go up to log base. And then I'm going to just calculate the log base 4.5 of 9. And it's going to tell me a number here that's going to be a little bit ugly, but it's 1.461, we'll say. So this is all equal to 1.461. That is an ugly number, but that equals x minus 1. Well, that's an easy equation. I can just add 1 to each side. So I add 1 here. This is going to give me 2.461 will equal just x because they will cancel. That is my answer for part B. So look, if they give you a base and they give you the argument, and just put it in your calculator and figure it out. Why don't you do D right now? Just do D right now. Pause the video and do D. Did say do D. So did you figure that out in your calculator? You get 1.389. Still can't believe I said do D. Now we want to subtract 2 from each side, right? So we subtract 2. I want to take that number there that I got, that decimal, I want to subtract 2. So I'm just going to leave it in my calculator. No need to round it or retype it in. I can just scroll up and get that number, and I'm going to subtract 2 because that's what I want to do, right? So I'm going to hit enter. And I get -0.6109. All right, so we'll just call it -0.611. And when I write that down, it's all equal to, these would cancel, and don't forget your negative sign, -x. So there's only one more thing to do. I got to get rid of that negative sign, so I divide by -1 or multiply by -1, however you want to do it. And I'm going to get x to equal here just 0.611. That'll be the answer for D. Whew, easy enough. Now let's look at C. Notice how C is a little different because in the base is actually the x. This is in the base of the log. So what I'm going to do is I'm going to rewrite this a little bit. Let's rewrite this as an exponential equation. So if I did that, I would get x plus 2. That would be the base. And it'd be raised to the exponent. The exponent's right there, right? In a logarithmic equation. So that means that x plus 2 cubed will equal 7.1. Do we know how to solve this? Well, let me remind you how to solve this. We want to get rid of a 3 here. We can take a third root or a cube root here of each side, and they will cancel each other. So we're going to be left with x plus 2. I'm going to take a cube root of 7.1. How do I do that? Well, in your calculator, you hit the math button, and then one of the choices is cube root. It's 4. And I can just type my 7.1. And everybody's having fun. And we get 1.921 or 1.922. So this all equals 1.922. Then we subtract 2 from each side. So as I said before, let's just leave this in a calculator. All right, we're leaving that number in. I need to subtract 2 from it. So I just hit subtract 2. And it leaves me with negative 0.078. Oh, that's ugly. So x is going to equal negative 0.078. And that's the best we can do for C. All right, so this one's a little different because the base is where the x was, the variable. So we're going to do that base to the third power. How do we cancel out raising something to the third power? We take a third root. We could also raise it to the 1/3 power. It'd do the same thing. Okay, let's look at E and F now. Let's start with E. For E, we have to remember that the natural log here, remember that ln, that's the natural log. That's log base E. Don't forget that. So we've already forgotten that. So that's log base E, right? So the exponent is E. I'm just going to write that down to remind you. All right, so E to the 3.8 equals the argument here of x plus 4. So that equals x plus 4. Well, guess what? I can just subtract 4 from each side. This is easy peasy. So I'm going to get E to the 3.8, whatever that number is, minus 4 will equal x. They cancel out. That is the solution. Well, I need to figure that out. I never figured that out. Your calculator here can do that for you. So we hit second. Right here's the E. So it tells us E to the, we want a 3.8. And then when we're all done, we want to subtract 4. Make sure you come out of that exponent. And we will get 40.701 on that. So we're going to say x is approximately equal to 40.071. I lied. 40.701, not 071. Finally got it right, though, eventually. Okay, so that's enough of these examples here. We're going to move on. So the next type of problem that we're going to do, these equations here, it's on page 673. Log base 2 of some expression here equals 4. So how do we solve this? Let's think about it. What would we do? So let's write it in exponential form first. So that means 2 to the 4th, right, would equal the argument, which is x squared minus 6x. Now you can kind of guess what's going to happen here. 2 to the 4th power. Don't say 8. Don't say 8. 2 to the 4th power. 2, 4, 8, 16. So 16 equals x squared minus 6x. At this point, we should recognize this is quadratic. So I'm going to set it equal to 0 by moving that 16 over. Don't forget to make it negative, right? And now this factors. Oh my goodness. Factoring, you're not done with factoring. So this is going to equal what? It's got to multiply 16. It's got to add a negative 6 here. It's going to multiply negative 16. So if we do, what do we got here? So we got to do x minus 8 and then an x plus 2. That's how that's going to factor, right? And then we set each one equal to 0. So let's scroll down a little bit here. We're going to get x minus 8 is going to equal 0, or x plus 2 is going to equal 0. So we get x equals 8, or x equals negative 2. So we get two answers to this, but we have to check them because remember that argument can't be negative. So when I plug an 8 in, I get 8 squared 64 minus 48. That's positive, good enough. When I plug a negative 2 in, I get negative 2 squared is 4 minus 6 times negative 2. That actually ends up being positive as well, so we're good to go. We have two different answers here, so we're good to go for 6A. That was fun. Let's try 6B. It's very similar. 6B. We have a base. This argument's got some quadratics in it, so part of you has to go like, this is going to eventually, you're going to have to factor, right? So let's rewrite this in, that's not a good sign. Let's rewrite this in exponential form. What happened right there? So 6 to the first power equals x squared plus x, right? So that's just 6. So we move the 6 over. We get 0 equals x squared plus x minus 6, right? So this factors into, what do we got? It's got to multiply to a negative 6. So multiplying to a negative 6, we're going to get x, probably going to use a 3 and a 2, right? And then it's got to be a positive on the inside, so it's going to be x plus 3, x minus 2. This is going to give us x equals negative 3 and x equals 2. And again, we got to check it to make sure this doesn't end up negative. I plug in a negative 3, that'd be 9 plus negative 3, that's positive. I plug a 2 in, I get 4 plus 2. That's positive. All right, we're good to go. So that's how you do 6B. We are flying. Now to page 674. This is a different type of problem. Look at this. Log of 5 plus log of x is going to equal 2. So there's two ways to do this. I'm going to show you probably the way that it's preferred. We're going to use our properties that we learned in the last lesson. Look, we have log base 10 of 5 and log base 10 of x. This is equal to the log of the product of those two factors, 5x, right? And that all equals 2. Well, guess what we can do now? The base here is 10, right? So we can rewrite this as 10 squared equals 5x. Or 10 squared is 100, right? So 100 equals 5x. We can solve that and get x equals 20. So it looks really difficult, but it's not too bad. The other way we could figure that out, I don't think we want to do this, but we'll try it because I'll show you everything. That way you got a toolbox that's full, right? So log base 5 plus the log of x equals 2. You could figure this out. That's a decimal. Log of 5 is a decimal. So we could say the log of x is going to be equal to 2 minus the log of 5, because I can just subtract the log of 5 from each side. And that's the log of x. So then what? I could do 10. I could make that a 10. So 10 to whatever this power is. So 10 to the power of 2 minus log of 5. Oh man, equals x. You don't want to do it this way. You don't want to do it. But I do want to show you it works. But you don't want to do it this way. The first way I did it was cooler. It's cooler. But let's try it this way. 2 minus log of 5. What's this going to give me? 20? What do we get the other way? 20. Woo! Thank goodness. They're the same. Get to keep my job, at least for another day. And that is number 2. Let's keep rolling. Let's look now at 675. We're going to go down to 3b. Okay, so what do we have here? Log base 2 of 8 plus 3 times. I'm going to do this one because of that 3 right there. Right? I can rewrite that. I can move that guy up. We know our rules, so that can go up on the x right here, like that, right? Okay, so now I'm going to rewrite this. The log base 2. Remember, we're adding these logs, so that'll equal the product of these two. So I'm going to call it 8 to the x cubed here. That's all going to equal 6. Well, how does that help us? Well, let's just see what happens here. This is the base. 2 raised to the 6th power is going to equal 8 times x cubed. All right, so 2 to the 6th power, 2, 4, 8. And then another 3 would be 64, right? So that's 64 equals 8x cubed. We're going to divide by 8, just like a regular equation here. What is 64 divided by 8? 64 divided by 8 is 8. So they will cancel, and we'll get 8 equals x to the 3rd power. Well, what number to the 3rd power is 8? 2, 4, 8. X equals 2. Wasn't too bad, was it? Okay, so that's not too bad. We could have done that. The other way you could have done it, you could have figured this out as a decimal. Actually, it'd tell you 3. Then you could subtract that from each side, divide by 3. You get the same answer that way. Let's try C as we're moving along. This is a natural log, right? So this is base E. It's just log base E. So it says subtract. So we know from our rules that this is all equal to, if we condense it, the natural log of 18x divided by 6. Okay, that all equals 2. What I'm going to do is reduce this a little bit. I don't need that. 18 over 6 is 3. So this is really the natural log of 3x is all equal to 2. So how could I solve that? This is base E. I'll put a little e down there. So e squared is going to be equal to 3x. I'm just rewriting it in exponential form. I can divide by 3 each side. These cancel, and we get what? X is going to equal e squared over 3. That is a funny looking e. Let's get the calculator out. I get 2.463. So 2.463 is equal to x. We're going to keep going to the nearest thousandth. So that's how you'd solve that one. It's ugly, but hey, you got to work with it, right? I mean, so page 676 now. I know we've done a lot of equations. We're going to keep going here and bust out a couple more, and then we'll be done. promise you that. So this is number 5. It says log base 3 of x minus 4 plus log base 3. Notice how it's the same log there. So using my properties, because we're adding, I can just say that equals log base 3 of x minus 4 times x plus 2, right? So I can just condense those logs together, and this all equals just 3. Okay, so now I can rewrite this in exponential form. That's what I would do. So 3 to the third power, we'll write it like that, equals, and then the argument here, which is x minus 4 times x plus 2. So now it just becomes an algebra problem, right? So if I expand on the right here and I multiply this all out, I'm going to get x squared. We get a plus 2x minus 4x. So that gives us a minus 2x and then a minus 8. And that all equals 3 to the third power, which is 27. Guess what we're going to have to do? You guessed it. Move everything to one side. Use the zero product property. So these cancel out. We get 0 equals x squared minus 2x. What do we get here? Minus 35. This will factor. What? We're still factoring? We are still factoring. This has got to multiply to 35, but give you a negative 2. That's going to be x minus 7 and x plus 5. That's going to give us the answers of x equals positive 7 and x equals negative 5. So I'm just going to check those up here. A negative 5 minus 4. Check that out. When I plug that negative 5 in right here, I'm going to plug, well, actually I plug it in right there. But negative 5 minus 4, that gives me a negative 9. Remember how the argument can't be negative? So this is extraneous. Now, if you check the 7, we're good to go. But you have to check both solutions in the original equation to make sure that we don't have a negative argument. Because remember, we can never have a negative argument. Woo! Unless you get married. Never mind. Let's move on to 7a on 677. Check out this. All right, so here's what I noticed. We have a common log here, and you're adding them. So can we put those together? Yes, we can. So let's do that. That is equal to the log of x plus 3 times x. All right. Now on the left, I see we got a 2 there. I kind of want to, I want to divide by 2 and get it out of the way, but that just creates messes over here. So I'm going to take that 2 and I'm going to put it up on top of this argument here. So we're going to get log of x plus 1 squared. Okay, equals the log of x, we have common bases here, times x plus 3. One of the things you can think about is this means the exponent I put on 10 to get this right here. This is the exponent I put on 10 to get this right here. I'm going to put both of these on 10. So this is kind of the opposite. You know how when we have a base, we take the log? Well, here we have logs, so I'm going to put it as an exponent on a base. And guess what happens? They kind of cancel. So you're going to be left with x plus 1 squared, right? This is the exponent I put on 10 to get x plus 1 squared. I'm putting that exponent on 10. And guess what I get? X plus 1 squared. And that's going to all equal. Over here we have the exponent put on 10 to get x times x plus 3. I'm putting that as an exponent on 10, so I'm going to get x times x plus 3. I know that double talk can be confusing sometimes, so just remember this. If you have a log and the base is 10, if you raise 10 to that power, it just gives you the argument. That is what the rule is. But then we can start doing some algebra here. We're going to multiply that out. This is all equal to, it's x plus 1 times x plus 1. So you get x squared plus 2x plus 1. That's what you get when you square that out, is equal to x squared plus 3x. Now we can subtract x squared from each side. Goes away. We can move the 2x over to this side. We get x, and it's equal to 1. Done. So all of this work, and you get x equals 1. That is sad, but also kind of a relief, if you hear me, right? I mean, it's sad, but also a relief. Okay, let's go to page 678. Let's skip B. We'll go down to C. We'll do that one because this one has a natural log, and I love natural logs. Let's rewrite this. We're going to use our properties again. We're going to put those together as a product. So the natural log of x minus 3 times x minus 2 is all going to equal the natural log of 2x plus 24. Now, as I said before, this is log base e. So it's the exponent I use on e to get this argument. If I use that on e, if I raise e to this power, and I raise the e to this power on the right, These will get rid of each other, and I'll be left with x minus 3 times x minus 2. How about that? Will equal, these will get rid of each other, 2x plus 24. It's very similar to the last one, but we're going to use e here because it's the natural log. If I multiply this all out, I get x squared minus 5x plus 6. That is going to equal 2x plus 24. I can move this all to one side, right? So I get x squared minus 7x. And then I subtract 24. I get minus 18. That looks good to me because now I can do x minus 2 and x minus 9 and x plus 2. I was thinking ahead. And we get x equals 9 and x equals negative 2. Guess what I need to check? Check out. I plug in a 9. Everything's good. Plug in a negative 2. Right here we get negative 2 minus 3. That's going to end up being negative. Can't have that. So this is extraneous. We have one more to do. Is that all we have to do? Please tell me. Oh my God, we've reached the last one. Done so many equations. I'm so happy now. All right, let's do this last problem, D, right here. We have 2 times log base 3 of x, and we have both log base 3's over here. I'm going to rewrite this like I normally do here. Log base 3 of 4 times 16, right? I mean, that's basically what the rule is. It's going to be the product of those two. But I know, well, let me write this out. I don't get too crazy here. All right, so I know, I don't know what I know here. This is log base 3 of 64 equals 2 times, you know what I'm going to do? I'm going to put that up top. Put that up top, right there. This is equal to log base 3 of x squared. All right, now they're both isolated with log base 3's. Guess what I can do now? Just like we did before. 3 to that power, 3 to that power. This will cancel this. I'll be left with x squared. That is a fat marker. This will cancel this. I'm left with 64. I will get x equals plus and minus 8. You got to remember, we have a positive and a negative, but I'm going to plug it back in and check it out. And if I plug in a negative 8, that will not work right there. Can't have a negative argument. So that is extraneous. So my final answer here is x equals 8. This video was 40 minutes. I'm going to chop it into 2 videos, lesson 3 and lesson 4. You're welcome for that. I'm going to bring back those eggs for you, though. Mr. Kelly in K-Town. Remember, it's nice to be important. It's more important to be nice. See you.
All right, 1, 2, 3, 4, 5, 6, 7. That's right. 1, 2, 3.